Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq. In the previous lecture we start probability distribution. We learn what is probability distribution. We learn what is random variable. We learn what is discrete random variable. In this section we will define discrete probability function. So discrete probability function is used to develop the probability distribution table for an experiment. And what is probability distribution table? Probability distribution table will simply list the values of the random variable of the experiment, as well as probability distribution table will list the probabilities of the values of the random variable. So simply we can define that discrete probability function is used to list the values of the random variable in a table, as well as to list the probabilities of the values of the random variable in a discrete probability distribution table. So this is all about the discrete probability function, or simply we can say that discrete probability distribution function is used to distribute one probability over the entire values of the random variable of an experiment. We will clarify this by putting one example. Method to assign probabilities to the discrete random variable means how we will assign probability to each value of the random variable to develop the discrete probability distribution table, to list the values of the random variable, as well as to list the probabilities of the values of the random variable. So in this section we will learn method to assign probabilities to the discrete random variable values. For example, this is example. Toss a coin twice and describe the outcome head mathematically as discrete random variable. Note, head as discrete random variable can assume three values as given below. Head can be 0, can be 1, can be 2. We discussed these all things in the previous example. Now in the discrete probability function, we will just list the values of the random variable, and we will learn how to assign probabilities to these random variable. So discrete probability function or discrete probability distribution function is used to assign probabilities to the values of the random variable. So how we can assign probabilities to the values of the discrete random variable, we will learn in this section. Suppose our discrete random variable symbol is head. So what is experiment? Experiment is toss a coin. When we toss a coin, so two outcomes are possible, head or tail. In this example, we are targeting the outcome head of the experiment toss a coin. So I am defining this experimental outcome head as a random variable by mathematical values, and we define that when we define the experimental outcome of an experiment by mathematical values, then we call that experimental outcome as random variable. So in here, experimental outcome is head, and I am defining as mathematical value 0, 1, 2. So this head is random variable. And now in the discrete probability distribution function, we will know how to assign probabilities to the values of the random variable. The random variable is head, its value is 0, its value is 1, its value is 2. So how we can assign probabilities, we will learn in this section, probability distribution function. So discrete probability distribution function is used to assign probabilities to the values of the random variable. Our discrete probability function is used to list the probabilities of the random variable of the values of the random variable. Our discrete probability function is used to develop the discrete probability distribution table. Discrete probability distribution table include both values of the random variable as well as probabilities of the random variable. So we will learn how to assign probabilities to the values of the random variable. Probability of zero head means what are the chances that when we toss a coin twice and there is no head, we are calculating the chances. So probability of zero head means when we toss a coin twice, so both are tail, probability of tail and tail. This TT means that when we toss a coin one time, so there is tail, first tail on the up face of the coin. When we again toss a coin, so again there is a tail on the up face of the coin, so we have two tails, so no head, zero head. These two tail means zero head. What are the chances that there will be no head? Probability of zero head mean probability of tail. So probability of zero is equal to probability of tail ZERP multiplied by probability of tail. So probability of zero means probability of tail, that is 0.50. We know that when we toss a coin, so both outcomes, head and tail, are possible. In each outcome, head also carry 50% chances, 0.50, and tail also carry 50% chances. So we calculate this, we study this in the previous lessons. Probability of tail is 0.50 and probability of tail is again 0.50. So probability of 0 is equal to 0.50 multiplied by 0.50 and probability of 0 is equal to 0.25. What does this mean, probability of 0 head 0.25? What is its interpretation? So interpretation means 25% chances that one means one who is tossing, who lose both tosses. 25% chances of zero head when we toss a coin twice. Let me again repeat that where we got this 0.50 and 0.50. Look, when we toss a coin, so two outcomes are possible. Maybe there will be head on the up face of the coin or there will be tail on the up face of the coin. So both head and tail both carry equal chances, 50% chances that there will be head on the up face of the coin and 50% chances that there will be tail on the up face of the coin. So the probability of tail is 0.50 multiplied by 0.50 and now we have the probability of zero head 0.25. This means 25% chances that when we toss a coin twice and there is zero head, or even in a single toss head does not appear. Now the probability of one head. How we can assign probability to one head when we toss a coin twice. So probability of 1 is equal to probability of head tail plus probability of tail head. Now what does this mean? Head tail, what does this head tail mean? This means that if we toss a coin first time, so there appear head on the up face of the coin, but when we toss second time, so there appear tail on the up face of the coin. So possibility is this, that first head appear and then tail appear. So in two tosses one time is head. Plus this is also possible that when we first time toss, so first time appear tail on the up face of the coin, and when we second time toss, so head appear on the up face of the coin. So in both tosses one time tail appear and one time head appear. So again the value of head is 1. So how we can assign probability to one head? So probability of one head, probability of head multiplied by probability of tail plus probability of tail multiplied by probability of head. Probability of one head is equal to 0.50 steric 0.50 plus 0.50 steric 0.50, because both head and tail carry 50% chances. 50% chances that there will be head on the up face of the coin, or 50% chances that there will be tail on the up face of the coin, So we assign 50% probability to both head and tail, and now 0.50 multiplied by 0.50 is equal to 0.25, and 0.50 multiplied by 0.50 is equal to 0.25. Probability of 0 is equal to 0.50. What does this mean? This means that 50% chances when we toss a coin twice, 50% chances that only one time appear head and one time appear tail on the up face of the coin. So in two tosses, the chances of one head is 50% that we calculate. Let me again repeat that. What does this mean? Probability of HT plus probability of TH. This means that this is possible that when we first time toss a coin, so head appear, and this is also possible when we second time toss a coin, so tail appear. So first time head, second time tail, so out of both tosses one time head appear. But this is also possible that when we first time toss, so tail appear, and when we second time toss, head appear. So again in two tosses one time head only. So the probability of one head carry these two possibilities. That is why we develop probability of 0 head 50%, means 50% chances that there will be head on the up face of the coin in two tosses one time. So this is interpretation. Now the probability of two heads. The probability of two heads mean if we toss a coin twice, so what are the chances? Estimate, calculate that both times head will appear. So probability of two tosses mean probability of head and head. What does this mean? What is its interpretation? Head means that when we toss a coin, one time head appear on the up face of the coin. When we toss second time a coin, so second time again head appear on the up face of the coin. So probability of two head we will write like this: probability of head and head. So probability of two head is equal to probability of head zarb probability of head. Probability of 2 is equal to 0.50 multiplied by 0.50. Probability of two heads is equal to 0.25. Now this 0.50 means that the chances that there will be head in both tosses one time, that is 50%. And 50% chances that when we toss a coin twice, so one time head will be appear, that is 50% chances, and this is also 50. When we multiply, we calculate the chances of two heads. 25% chances that when one win 25% chances that one win both tosses head. It's mean that 25% chances that one who is tossing a coin, he win both time the tosses and both time appear head on the up face of the coin. So this is 25% chances that one win both tosses, means head H appear is on the up face of the coin in both tosses. So now we estimate, we calculate probability for the 0 head, probability for the 1 head, probability for the 2 head. Now I am listing, look, we define that probability distribution function will develop the probability distribution table, and this table will include values of the random variable as well as corresponding probabilities of the values of the random variable. So probability distribution table is this. This table lists the values and probabilities of the discrete random variable head. So discrete random variable head values are 0, 1, 2, and probabilities of the random variable head are given. Probability of 0 head is 0.25. We estimate. This is in here. You can check from here. Probability of 0 head 0.25 we calculate. Now probability of 1 we calculate 0.50, and probability of 2 heads again we calculate, that is 0.25. So probability distribution function divide one probability over the entire values of the random variable. And now look here, we divide this, when we add these probabilities, total probability is 1, and we divide this one probability over the 3 values of the random variable head. 0.25, 25% chances that no head, 50% chances that one time head and one time tail, and 25% chances that both time head appear when we toss a coin twice. So probability distribution table lists the values of the random variable as well as the probabilities of the values of the random variable, and simply we can say that this is discrete probability distribution function, because discrete probability distribution function divide one probability over the entire values of the random variables, and this function developed the discrete probability distribution table. Let me repeat again this example shortly, that what is discrete probability function. Discrete probability distribution function discrete probability distribution function calculate probabilities for the values of the random variable of an experiment. And now we consider experiment toss a coin twice, and the random variable is head, and the possible values of the random variable head is 0, 1, 2. Now using probability distribution function, how we can assign values to the probabilities to the values of the random variable head. This is random variable head, and it can assume three values 0, 1, 2. Now we will assign probability to the 0 head, means no head when we toss a coin twice. So when no head mean both are tail, so probability of 0 we will write like this, dear student, probability of 0 is equal to probability of tail. Both times tail appear on the up face of the coin when we toss a coin twice. So probability of 0 head we will write like this, probability of tail, and tail mean both times tail appear, no head. So probability of 0, probability of tail multiplied by probability of tail, probability of 0 head is equal to 0.50, 0.50. What does this 0.50 mean? This means that when we toss a coin, so 50% chances that there will be head and 50% chances that there will be tail. So the probability of tail is 50%. So 0.50 is equal to 0.25. What does this mean? Probability of 0 is equal to 0.25. This means that 25% chances that when we toss a coin twice, both times tail appear, head does not appear. Now the probability of one head. So probability of one head mean when we toss a coin twice, so only one time head appear and one time tail appear. How much are the chances? We will use discrete probability distribution function to assign probability to one head when we toss a coin twice. So probability of one head we will write like this, probability of head tail plus probability of tail head. What does this mean? This means that when we toss a coin first time, so head appear on the up face of the coin. But when we toss a coin second time, so tail appear on the up face of the coin. So head tail, this is possible. Plus this is also possible when we toss a coin first time, tail appear. And when we toss a coin second time, so head appear on the up face of the coin. So these are two possibilities of the one head. Now we will assign probability. Probability of 1 is equal to probability of head multiplied by probability of tail plus probability of tail multiplied by probability of head. Now we know that when we toss a coin, two outcomes are possible, head or tail, and the probability of each outcome is 50%. 50% chances that head will appear, 50% chances that tail will appear. So probability of head is also 50% multiplied by probability of tail is also 50%. 50% multiplied by 50%, probability of 0 is equal to 0.25 plus 0.25, and probability of 0 is equal to 0.50. What does this mean? This means that 50% chances that when we toss a coin twice, so one time head appear. Now probability of two heads. What does this mean? Probability of two heads mean that what are the chances that when we toss a coin twice, so both time head appear. We will assign probability using this way. Probability of two heads is equal to probability of head and head. Both times head appear when we toss a coin twice. Probability of HH means that when we toss a coin twice, so first time when we toss, head appear on the up face of the coin, and second time when we again toss, head appear on the up face of the coin. So probability of two head is equal to probability of head multiplied by probability of head. Again, probability of 2 is equal to 0.50 multiplied by 0.50, because both outcomes of tossing a coin carry equal chances. 50% chances that there will be head on the up face of the coin, and 50% chances that there will be tail on the up face of the coin. So that is why we assign probability to head 0.50 and again probability to head 0.50. Probability of 2 is equal to 0.25. What does this mean? Interpretation. This means 25% chances that one win both tosses, means 25% chances that when we toss first time, head appear on the up face of the coin, and when we toss second time, again head appear on the up face of the coin. In this way, we will develop probabilities for the values of the random variable. In this way, we will assign probabilities to the value of the random variable, and now discrete probability distribution table will list the values of the random variables and the corresponding probabilities of the values of the random variables. So this first column represent the discrete random variable head values, 0 head, 1 head, 2, and second column represent the probabilities of the values of the random variable. Look, this 25% is the probability of 0 head, 50% is the probability of 1 head, 25% is the probability that both times head appear, 2 head. So when we add all these probabilities, total probability is equal to 1. This means that discrete probability distribution function spread over, divide, distribute one probability over the entire values of the random variable.